Hey Joshua, this video is on your about your Unit 5 Part B exam. I just wanted to go over this number 4 quickly with you. I see you didn't really you weren't able to do this exactly, so I wanted to kind of go over with you, show you what these generally look like. You seem to know everything else pretty well, so once you know that, I think you'll be able to figure this one out pretty quickly. So the first thing I just want you to see is what a graph of secant looks like. It's these. So I mean, I just googled graph of secant. It's kind of these alternating shapes, and we'll kind of see why this is how it is. So, but I like this to start looking at this one. As you can see, this is just a graph of sine. Oh, so this is cosecant. Sorry, we're going to look at secant. But this is the same idea. So with sine and cosecant, right? So cosecant is just 1 over sine. So, right, like sine of x, or so 1 over sine of x equals CSC x, right? So it's basically just the inverse. And when we're going to do cosecant, right, cosine and secant, sorry, I keep messing all these names up, is going to be a similar thing. So the first thing you want to do is graph the cosine function that looks identical to the secant function. See, these are identical, except this one says secant and this one says cosine. Okay, because these points, right, are going to be the minimums and maximums for all those other, for all these shapes, right? So you can see that the minimums and maximums correspond. So that's why I like to graph the cosine first. The next thing you kind of want to notice is how these periods work. So basically, like an entire period, right? This is sine from 0 to 2 pi. So basically, you have these asymptotes at the half period, half period, half period, and then you'll have, you know, one upward facing secant and one downward facing secant. And again, we'll talk about the shape in a second. So again, you're going to want to look at all the minimums and maximums. We see that the period here, right? So it goes from let's see, so from negative negative 3 pi, or negative pi over 2 to 5 pi over 2. So the period here is just 2 pi, right? Just shifted a little bit. Okay, so again, yeah, I think you know how to graph this cosine function well. And again, I mean, notice like the amplitudes and stuff, right? Amplitude is 3. Or sorry, well, the amplitude is, what is it? It's from like pi over 2. Actually, I'm not sure. I have to think about that for a sec. But that's not the point. We could figure that out pretty easily. Okay, so anyway, so we have the period, right? We'd basically, actually, let me see if we can draw on this for a sec. Okay. Right, so we're going to be drawing on this, right? So we're basically going to have something like this, something like this. Well, it's not going to be that wide. And again, right, so on the half period, so if we said the period is 2 pi, so pi over 2, pi over 2. Sorry, I'm messing this up. Let me see what this actually looks like. So, okay, yeah, that's perfect. So, right, so we have one here. There's going to be an asymptote at each, is it half period or quarter period? It's, yeah, so there should be an asymptote at each half period. So it looks like the asymptotes are right at 0. Then there's an asymptote at pi, right? Pi should be, so if we can get y equals pi, oh no, x equals pi, equals pi, right? So there's an asymptote at 0, an asymptote at pi, an asymptote at 2 pi, right? So you're going to kind of, you look at the minimums and maximums, draw them, draw the asymptote. Why do we get this shape? Well, it literally is the inverse of cosine. So whenever you have, some number for cosine, it's kind of 1 over that for secant. So, if you have a decimal, it makes it a really large number. So that's the point. For what values, so let's look at cosine. Let's look at cosine of x. Cosine of x, right, at pi over 2, it's 0. So for our problem, when we have cosine x minus pi over 2, so cosine is 0 at pi, right? So then we'll get pi over 2, and that'll be 0. So the point is, as cosine approaches, as x approaches these numbers like 0 and pi, right? Then we're going to get 1 over cosine of pi over 2, or negative pi over 2, and that will be really close. That will be a really close number to 0, which 1 over a really small number is a really big number. So hence we get these numbers going to a really big number, right? We're basically getting as close to 0 as we can, but we can't actually get 1 over 0 because that's undefined, and that's where we get these asymptotes. I hope that makes sense. If it doesn't, I'd be happy to try to re-record this, talk to you about it. Feel free to call me. I know your dad said you're traveling, so I just wanted to get this to you. Hope this helps, and please let me know when you get back if you want to go over this. I'd be happy to. All right, take care.